Hello, hello, amazing students. Mr. Viteri in full effect today. You can call me Mr. Hollywood, aka Pitbull. Just kidding, just kidding. Welcome to the show. We are in Unit 8. Oh my gosh, it is a blessing that we have made it this far. This is a big unit, so let's get right to it. It's about 14 parts to it. But I think we have introduced many of the topics already, so we don't have to delve into too much detail. But we could basically use this as almost a review and go and get the specifics of certain things just in case we missed it before. All right, let's go. So this whole unit is about pollution, aquatic pollution and terrestrial pollution. So what really is pollution when we think about it? Pollution is a general term, and it basically means that we're going to transform an area that will damage organisms. And that could be any type of area, whether it is land, air, or water. Typically, anything that makes something hurt in nature is going to be caused pollution. So, for instance, if I had some bad gases in the atmosphere, sulfur dioxide, carbon monoxide, that would be deemed as air pollution. If I had some chemicals in the water like mercury or lead, then that would be water pollution. If I have, let's say, in this example, I think there's a straw in the sea turtle's nose. That would be an example of litter pollution, which was in the water. So anything that makes an environment inhabitable or hurts an organism is going to be deemed pollution. There are many different types: waste pollution, air pollution, soil pollution, water pollution, litter pollution. All of these can have catastrophic effects on organisms. Okay, so here are some examples. I'm sorry if I depress you with these pictures. Just trying to drive home a point here. Okay, so this is an example of litter pollution, specifically in our waterways. And why I say waterways is that even if we throw something in the street or in our yard, when it rains, everything goes downhill. It goes into our drains, and the drains go into our waterways. And so, hopefully you're not the student that's polluting, but most of that pollution is going to end up in a river, end up in a waterway, Raritan Bay, where we live. And there are going to be certain organisms that get trapped in it. They could suffocate. It could block their intestinal. It can cause intestinal blockages, and then eventually cause them to die. I want you to know specifically these terms. So, what can litter pollution actually do? It's a choking hazard, and organisms will choke, suffocate, and die. It could also cause intestinal blockages, and this will prevent an organism from eating new food, which then results in the organism starving and die. I'm saying it this way because I want you to be able to explain this in a free response question, just in case there's a type of question like that. Because specifics, specifically when there's an explain type question, is very, very important. And to elaborate on details is also very, very important. So, this is an example of litter pollution, which is on the CED as one of the objectives you should definitely know. All right. No intestinal blockages, no choking hazards. These are iconic images that we see that get impressioned in our heads, and then we don't really forget them. And it produces us to want to change. Okay. And we can change, we can do better. All right. So here's a seal with, I think, a piece of maybe a bucket, remnants of a bucket trapped around its neck. And these are just small plastic particles that are being eaten by an albatross or some type of large bird here. All right. Very sad when you think about it. Okay. So here's an example of water pollution. Now, farms are typically, and I'll say conventional farms or modern farms who use fertilizers, chemical fertilizers, are going to uh, be a source of pollution. So, whatever is sprayed on this crop, whether it be a pesticide, um, an herbicide, any type of pesticide, um, it could come off in the runoff. And in the runoff, I also see sediment buildup. And so we also know that sediment is the number one by volume, bulk volume, water pollutant. And so this clay is being transported eventually into a waterway. Okay, it's bringing with it Nitrogen, phosphorus, and potassium, which are the two principal components that are going to cause eutrophication. Not only is it doing that, it's bringing the pesticides with it as well. Now, once it gets into that waterway, it could cause death of aquatic organisms and frogs. Frogs are like an indicator species. Those indicator species mean sensitive species that tell us something is wrong. So we might look at the water and be like, oh, it's beautiful and clear. But if we see a dead frog in there, it's like, what happened to that frog? Okay. So this is what this whole unit is all about. Okay. Let's continue. Soil pollution. We have litter pollution. Okay. And if you have a litter and then you have cow manures, then when it rains, this is going to percolate through the ground and there's going to be soil pollution. And depending on what type of waste products you have there, you may not be able to use that soil. You destroy the soil, you destroy areas where you can farm. If you destroy areas where you can farm, you don't have no food. You don't have no food, you have war. All right, you don't have food security. All right, and here's another area, and this looks like acid mine drainage, and this will also pollute the soil. Typically, it's going to be having heavy metals like lead, mercury, cadmium, arsenic. Okay, and that's we'll explain that a little bit later. So don't be afraid if you don't know too much of heavy metals. I know we haven't talked about that, but we will with this presentation. Okay, and finally, air pollution. Okay, any type of thing that we burn that goes into the gaseous phase, we are going to inhale it, and depending on the toxins, we can hurt ourselves. All right, we've already talked about radon is the second leading cause of lung cancer. Cigarette smoke is the number one. We talked about carbon monoxide, and carbon monoxide can basically kill you because it has a greater affinity towards hemoglobin than oxygen. We talked about mold and bacteria also being airborne particles that could potentially cause some damage. All right, let's continue. Now, how can we categorize pollution? We're going to categorize them in these two big categories as point and non-point source pollution. What is the difference between the two? One, you can easily identify. You can point towards it. I see that pollution. It's coming from that sewage facility. It's coming from that car who's leaking oil all over the floor. It's coming from that person who's throwing it on the floor right now. That is point source pollution if you're able to point it. Now, non-point is harder you really don't know exactly where it's coming from. Rather, it's coming from a large area. Okay, so agricultural runoff is typically deemed as non-point source pollution. You could say you're pointing at the farm, but you would have to point like this, right? Because a farm isn't necessarily small. A farm is ginormous, right? So you don't know exactly what plant that's coming from or what type of field it's coming from. So typically runoff of streets, of farms, sediment runoff, when you don't know where it's coming from, are going to be examples of non-point source pollution. So these are two broad categories. One, I know where it's coming from. The other one, it's coming from multiple sources or area source pollutants, it's also called. And it's typically involved with runoff. Let's look at this diagram here. In this diagram, let's look at the point sources. Those are easier. Point source pollution would be a factory with a discharge pipe going into a waterway. This is pointing at a vessel that's leaking oil. So these would be point source pollutions. Non-point source pollutions would be a road. And I know you're saying you're pointing at that exact road, but the road is ginormous. Okay, so it's coming. The oil might have came from a car, but you don't know what car it came from. It could be coming from multiple cars, so on and so forth. So roads could be associated with that. The development of construction, you might not know exactly where it's being coming from, so that's a non-point source pollution. Farms, again, with the runoff, and city runoff as well. All right, so how does pollution necessarily affect our environment? Okay, I know we've talked about coral reefs before and basically told you how important it is. But I want to read this one to you. Humans can pollute habitat for organisms, which would limit population growth. That's something that you could say on a rubric. Pollution can limit population growth. Ability to maintain homeostasis. I like that word. All right, that means your body's ability to remain in balance, pH balance, electron balance, electrolyte balance, water balance, any type of balance. Okay, reproduction rates and survival. I love how how precise that I got that directly from the CED. So try to understand. if you were trying to write an answer for a rubric, you would use terms like this. It could, so pollution can hurt reproduction rates because, if you were ever breeding dogs, right? Or if my wife was having a baby and she was given like vitamins so to make sure that the baby is healthy. If you're ever breeding a dog, dogs, you should, if you're trying to do it professionally, you should have a very nutritious diet. You can even give them vitamins to make sure that their offspring are going to be as healthy as possible. Now, if they can't find food because it's polluted, if they have swallowed plastic, their intestinal blockages, the water isn't right, the pH isn't right, something is hurting them, then that's going to affect their offspring. So reproduction rates, their survival themselves, all right, their ability to grow. All right, water pollutants can stop organisms from growing and reaching their potential growth. Stuff like clams, if there's ocean acidification going on, they won't develop shells, so their growth is stunted. All right. Okay. Now specifically, how can humans be destroying coral reefs? This could be a laundry list, but uh, you know, some places do use destructive practices such as dynamite fishing, and throw a piece of dynamite in the water, boom, all the dead fish float to the top. This also causes the coral to chip off and break, and that coral is so valuable. And it has to be maintained strong so it can block the waves and create a barrier of erosion before it basically hits land. Okay. Bottom trolling, that fishing method that drags a net along the bottom, could also destroy corals. And these guys look like they're having a great time, but they're touching the corals. You're going to chip off a fragment and you might be smothering one of these little you know polyps, these corals themselves, and you could be destroying them. So if you do go visit a coral reef, I recommend go doing that. That's a beautiful thing to learn and appreciate them, but do not touch them, do not take some home, and make sure that the place that you're going is using sustainable practices as well. So once again, how do humans destroy corals? Well, we could use dynamite, bottom trolling, and also recreational activities, or basically stealing some of that coral. All right. I think that's called coral looting. All right. Coral looting. Now, that I think I've seen that on a rubric somewhere. All right. So now, past problem. Now, human impacts continue. So, what else can happen to corals? So, there's basically two things that people get misconceptions about, and those two things are going to be coral bleaching and ocean acidification. So, in coral bleaching, this occurs because the oceans are warming. They're warming so much that the photosynthetic algae is not reproducing, and and they begin to die, and they live in a symbiotic mutualistic relationship with the corals and the algae. If the algae dies, then the corals soon die afterwards. So look at this beautiful picture. This is a healthy coral. It has that photosynthetic algae that gives coral its color. Without the photosynthetic algae, the corals become bleached, and eventually they die and decompose. Okay, so this is a picture of coral bleaching. All right, and I believe this is a picture of coral bleaching that has occurred, but also ocean acidification. Now, since CO2 is rising, more carbonic acid is becoming more present in our oceans, which is decreasing the pH, which then causes the corals to dissolve. All right. This allows any shell-bearing critters that live in the water to dissolve, and their shells are not as hard, and then they basically are easily predated on. Okay, so it destroys their fitness, their ability to survive and reproduce. There's also sediment runoff that destroys coral. So, like I showed you that image of that runoff from a farm. Well, that dark sediment, you can't see through it. Sunlight can't penetrate through it. That's going to increase the turbidity, decrease photosynthesis, aka primary productivity, and destroy or hurt that place. It's going to hurt the homeostasis of the plants. It's going to decrease its productivity. And if you decrease the productivity, the organisms that depend on that productivity will also be affected. Oh, I love it how we're putting so many different things together. Okay, let's continue. Now, another way humans can negatively affect the environment is by oil pollution, okay, or oil spills. Now, the most recent huge oil spill, because these things happen all the time, typically they're smaller in number, but when it becomes huge, it becomes an issue. I don't know if you were even born by then. What's the 2008? Yeah, you were born, but you were probably a toddler in 2010. This was BP oil spill. So I lived through this, and so I remember it vividly. And this happened in the Gulf of Mexico, and there was an ocean drilling operation going on. And so, if you imagine this, it's basically a an island, not an island. I mean, it's like a factory that they basically put in the ocean. There's a drill that goes down through the water into the ocean bottom, and you drill and you suck up the oil. Now, the issue there is what happens if there's a leak. So that's exactly what happened. The thing blew up. There's a leak. Now the ocean is spewing. The hole is still there, so it's spewing all this oil out. And so that is BP oil spill. And so I think these are some pictures that result from that. So what can the oil do? All right. And once again, we're going to get this very specific. The oil can get stuck in the feathers of certain organisms. It has to be birds. It could get stuck in the feathers, or it could get stuck on the skin, like on seals or on their fur, and it slows their ability to fly, to maneuver, to move, and they end up drowning and starving. Okay, and so this is an image of some type of, I think it's a cormorant, of a bird. Unfortunately, there's a sea turtle covered in oil, um, and yeah, I've seen those Dawn commercials where they try to get the oil off, but a lot of these organisms die regardless because of the stress that's involved. Like, imagine this, like an alien just picks you up, just takes you a bath. You'd probably be freaking out the whole entire time, like, oh my god, this is the moment, this is the moment. The person's just trying to help you, but the organism does not know that it's a wild creature, so they are flipping out, and sometimes that stress just causes that organisms to die. So very, very sad. There was another oil spill, Exxon Valdez, in 1989. What can we do? What can we do to make this better? There have been some technologies that were developed, like a double hull system. What does that mean? The hull is the bottom of the boat. So they have one hull versus another hull. So just in case something hits the boat, then hopefully it didn't penetrate the other hull. All right. So how can we clean up an oil spill? There are typically four technologies that we use. The first one is a chemical dispersant. Now, oil floats on water, so it comes up to the top. And I remember with BP, it was just so bad. It was so bad. I think CNN had, or one of the news operations had a camera in the water, and it was just watching this oil, and it just had a live camera, and it was the saddest thing ever because you were seeing all this oil constantly be, just coming out from the ground. It's not like they could have just shut it off where there's a shut off switch. Um, the oil is spewing out because there's water pressure going into the hole, choosing the oil to go up. And so now that oil is going all over the place. Eventually, I think it was for like maybe 20 days, you just saw this oil just coming up. And they took the camera off because they tried 2 or 3 times previous to cap it. So what they were trying to do is inject concrete to spread and just cap it, but they failed. So I think they just took the camera out of there because they were just like, listen, people can't handle it anymore. People are protesting. People are upset. There's black oil on top of the water. Beach goers, there was oil on top of the beach in the Gulf. The fishers who go out can't go through that stuff. The fish all swam away or died. This was a really bad thing. So how can you get rid of it? So chemical dispersant, something like soap, and that's going to go on the oil. I don't want to talk like it's a great thing. It's not a great thing, but now we're screwed up already. So what do? Well, you put a big chemical on top of a chemical, and it could dissolve it. But typically, that has done, it allowed it to coagulate and then sink down to the bottom. Now, this is not necessarily a good thing, so understand that that's one of the objectives as well. Oil, as it breaks down, could start going to the bottom of the ocean and hurt bottom dwelling organisms, which could be the base of the food chain, and typically where eggs are going to be laid and so on and so forth. So, chemical dispersants is one of the technologies that are used. Another technology that can be used is just burn it all. Okay. Now, it stinks because it's not refined. So now you're talking about a crude oil, which is going to have its sulfur, it's going to have its contaminants, lead, it's going to have whatever it has, and it's basically going to be released into the atmosphere. So that's another way. It's a quick way. You won't be able to see it if you do it at nighttime. You know, you may not be able to see it. Another method would be skimmers. Now, skimmers are going to be like these, exactly what they sound like. Since they skim the top of the ocean, you can take two boats with a bunch of skimmers, and you could wrap around that oil spill, and you could pull it in some location. So skimmers will skim the oil on top and get into a concentrated area, and then you could use something to suck it up, and you could retrieve some of that oil.
Good morning, everyone. Today is Thursday,
Sorry for the disruptions, guys. So, like I was talking about before, skimmers, you can suck it up, you can retrieve some of that oil. It's costly, time consuming, and if you were an investor, would you invest this type of technology? It's not like oil spills happen all the time, so there's not a lot of like boats just ready to do this type of stuff. So anyhow, booms booms are going to be these flotation devices that are just a bunch of buoys that will trap the oil. So this is a way of trying to stop it from entering the beach, or try to put a cap on it of where it's going to spread out. So these are four technologies. Once again, chemical dispersants, you could burn it, you can use skimmers, or you could use booms. And you could check out this article down here if you have some extra time. Let's continue. Now, what can these oil spills do? We've already said that it can kill wildlife, but not only is it going to kill wildlife, it's going to affect ecotourism. That's a buzzword. Try to remember it. Ecotourism. I guess it's a combination between economics and ecosystems. Basically, you're going to pay to appreciate nature in some type of way. This would be going to a coral reef, going to a tropical rainforest, or going to a beach. If the oil is covering your beach, no one really wants to go there. The beach may actually be closed. All the revenue that is made from going to the beach is actually lost. So, financially speaking, ecotourism is affected by oil spills. Fishing industry also suffers because you have fish deaths, and fishing vessels have to go farther in search for fish. And some of that oil also sticks to the bottom, like we spoke about before, and will hurt ground dwelling organisms. Okay, so in the BP oil spill, all right, 200 million gallons of crude oil spilled. Then we put 1.8 million gallons of chemical dispersants. All right, 60% of the oil is left unaccounted for. All right, 75% of the residents exposed to crude oil dispersants have health problems. 12 out of 12 people exposed to oil spill pollutants had high levels of toxic compounds found in the crude oil. 40% of commercial and recreational fishing closed. Fishermen reported 80% drop in catches. And oystermen estimated 20 million, all right, loss of 20 million. Before the spill, a shrimper caught 4,000 pounds of brown shrimp in 4 days. Now he catches 800 pounds in a week. Yes, devastating effects of something like an oil spill. We have to do better. Okay. We spoke about this before. These are the dead zones that usually occur because of excess fertilizers, and we have the Mississippi River also feeding into the Gulf of Mexico. All right, so remember that because the Mississippi River goes through multiple states, typical states that use a lot of farming and livestock raising, there's going to be a lot of runoff that goes into that Mississippi River and feed into the Gulf of Mexico. So we're going to get a lot of NPK in there. And NPK, or rises in NPK, causes eutrophication, which eventually leads to low dissolved oxygen, which creates a dead zone. We're going to go more detail into dead zones. But understand the location. The Gulf of Mexico is next to Texas and between Louisiana. And here is a great image that shows you that look at your dissolved oxygen. Oh my God, organisms want like, the green color, right? But look, oh my gosh, we're over here. Hardly anything could live in that area. Okay. Here's another vocabulary term that I saw in the CED there. Oh, I'm sorry for the typo there. An oxygen sag curve is a plot of dissolved oxygen levels versus the distance from the source of pollution, usually in excess of nutrients and biological refuse. Wow, what did that say? I'll correct it later. Basically, it's going to say that the oxygen is going to decrease usually when there's a source pollution. So here, let's look at this diagram here. Dissolved oxygen is high in this area before the pollutant. The pollutant's going to come from the sewage treatment plant. BOT is relatively low. So look, low to high. Now, after the pollution site, dissolved oxygen falls, BOD starts to increase. This is your oxygen sag, okay? Now, the further you get away would be considered the recovery zone. So the dissolved oxygen starts to go back up and the BOD goes down. If you don't remember BOD, BOD is a biochemical oxygen demand, and that's going to be how much oxygen is demanded by the microbes that are doing the decomposition in that water. All right, let's continue. So here's another image. And in this image, it's clean over here. Dissolved oxygen is high. The pollution site, point source pollution site, the oxygen begins to decrease. Here's the oxygen sag. The BOD, the microbes start to reproduce like crazy because now they have a lot of food. They start demanding a lot of oxygen. As they get further and further away from the source, the BOD gradually decreases and the DO goes up. Once again, it's biochemical oxygen demand and dissolved oxygen. Look at these beautiful fish. Certain fish need 8 parts per million to live. Catfish can live in subpar aquatic conditions. So you see a nice catfish over here. It actually might be a cod. Okay, and so we're done for today. We'll continue with heavy metals tomorrow. I hope you enjoyed and learned something today. I'll talk to you.